All right, this is going to finish up our Chapter 12. I'm going to do the rest of Section 3 on energy conversion and then go into Section 4, which is on energy resources. So on your paper, you should see we're down to the important question that says, can there be any such thing as a perpetual motion machine? Yes or no? If you checked no, you would be correct. The drinking bird, which they show you at the bottom of 362, Mr. Graham and I both have one of these that we'll get out for you to see, would not be considered a perpetual motion machine because it's not in a closed system. It's called a drinking bird, not that it actually drinks the water, but the head gets wet and it uses thermal energy from the air to evaporate water to cause it to go up and down. So there's no such thing as really a perpetual motion machine that would put out exactly as much energy as it takes in. Energy efficiency is a comparison of the amount of energy before a conversion with the amount of useful energy after a conversion. This day and time, we have a lot of cars which use energy efficiency. A car with high energy efficiency can go further or farther than other cars with the same amount of gas. This is what the smart cars are trying to accomplish. Energy conversions that are more efficient then end up wasting a lot less energy. Newer cars tend to be a lot more energy efficient than older cars. Most new appliances now, like refrigerators, freezers, water heaters, are more energy efficient than they were back even when I was growing up 20, 30, 40, 50 years ago. So improving the efficiency of machines like cars is important because greater efficiency results in less waste. And if less energy is wasted, then we need less energy in order to operate that machine. And we've been watching on Channel 1 about energy resources, fossil fuels, especially in China with all the pollution. So an energy resource, and this starts Section 4, is a natural resource that can be converted into other forms of energy in order to do work. Fossil fuels are these energy resources that formed, millions of years ago. So we have two types. We have non-renewable resources and renewable resources. Non-renewable resources cannot be replaced or are replaced much more slowly than used. A good example of this are our fossil fuels. I guess I need to slow down a second and let you catch up. So, fossil fuels are energy resources formed from buried remains of plants and animals 1 million years ago. So it takes that long for coal, oil, natural gas to form down in the ground. So when we run out of our fossil fuels, we can't wait another 1 million years for those to build back up again. So that's the reason we have to try to conserve and be energy efficient. Renewable resources are naturally replaced more quickly than they can be used. Now, renewable resources are on page 367. Some of the renewable resources are solar energy, energy from water. This is what we use a lot here in Tennessee with the TVA, Tennessee Valley Authority. We can use the dams, the water coming over the dams, to generate our electricity. There's also wind energy There's geothermal energy, and then there is biomass. So all of these can be replaced more quickly than we can use them up. I mean, we have another 4.5 billion years before our solar energy runs out. So I think we're covered there. We've talked about energy from water. Wind energy is used in a lot of places where they have a lot of wind. It can't be used everywhere, so that would be one disadvantage. But places that have a lot of winds can use this with the turbines that you see at the bottom of 367 to generate electricity. Geothermal energy is simply taking the energy that is down in the Earth's crust, and power plants pump water underground next to this hot rock. The water returns to the surface as steam, and that turns a turbine that would turn a generator. So places like Hot Springs, North Carolina might possibly be able to use geothermal energy to its advantage. I think Hal Hennard put in place several years ago a way to use some geothermal energy. And biomass is, bio, remember, means life. So these are organic matter like plants, wood, waste that can be burned to release energy. And there are some countries that depend on biomass for their energy. Some places also use, when we're talking about geothermal, so some places like Iceland that have a lot of volcanic activity, they can use that geothermal energy to power plants for electricity as well. All right, so electric generators convert the chemical energy in fossil fuels into electrical energy that we can use. Nuclear energy is generated from radioactive elements like uranium, and nuclear energy is non-renewable. Once all of our uranium is used up, we won't have nuclear energy unless scientists come up with some other man-made radioactive element that could take the place of uranium. Now, I've already mentioned before about nuclear fission and nuclear fusion. Remember, fission is when the nucleus of the uranium atom is split into two smaller nuclei. A huge amount of energy is given off. And then nuclear fusion is the combining of a hydrogen atom with another hydrogen atom to produce helium. This is what takes place on the sun. Nobody has to tell the sun to do this. This is just naturally occurring in the sun. Two hydrogen atoms come together, fuse together, and give off an enormous amount of energy. It happens in our sun and in other stars as well. Now, the reason I circled combing is because it's misspelled. It should be combining. So make sure that you spell it correctly on your paper. All right, this wraps up Chapter 12. Make sure that you read the information that is in your book, and you should do fine when it comes test time.